Moon exploration. The moon shows us its smiling, man in the moon face every month, illuminated by the sun to varying degrees over the course of its orbit around us. However, thanks to its orbital dynamics, we only ever get to see that one hemisphere from Earth. The other hemisphere, the far side, is constantly concealed from us. Well, that's not strictly true. Libration, which is the gentle wobbling of the moon in the sky caused by changes in its position in its elliptical, i.e. non-circular, orbit around Earth, mean we can catch glimpses of small slivers of the far side. We can actually see 59% of the moon's surface from Earth at different times of the year. But until the first space missions to the moon flew around our natural satellite, what lay beyond on the far side was a mystery. It's often mistakenly thought that the far side of the moon is in darkness. Rather, it experiences day/night cycles just like the near side. When we see half of the moon being illuminated by the sun, giving it a half or crescent shape in the sky, half of the moon on the far side is being illuminated at the same time. When the moon is new, the far side is in full daylight instead. When the moon is full, it's nighttime on the far side. The reason we only see the one face is because of a phenomenon known as tidal locking. The moon rotates on its axis roughly once every 27 days, which is the same amount of time it takes to orbit the Earth. This means it is rotating at a rate that means we always see the same face, more or less, as it moves around Earth. There are 2 weeks of daylight and 2 weeks of night on every spot on the lunar surface. Charlie Duke, who was the lunar module pilot on the Apollo 16 mission, told all about space. It was early morning during the moon day at the Apollo 16 landing site, which was called Descartes. We were the 5th mission to land on the moon, and I can say that it really is a dramatic place. Our first glimpse of the mysterious far side came early in the space race, courtesy of the Soviet Union's Luna 3 spacecraft almost 60 years ago. In 1959, barely 2 years after placing Sputnik 1 in orbit, Russian engineers managed to send the spacecraft, which was crude by today's standards, into orbit around the moon and, for the first time, we got a good look at the mysterious far side. Luna 3 took 29 film images of the far side in total, which were photographically developed, fixed and dried on board. Remember, this was long before multi-megapixel cameras. Ironically, the film used had been stolen from American spy balloons, as it had to be sturdy and radiation-hardened. The spacecraft, using a combination of 2 camera systems, one wide field and one narrow field but higher resolution, and a crude onboard scanner, could then transmit the processed images, which were spot scanned from the photographs, back to the receiving station in the former Soviet Union. Although only 17 of the 29 taken were transmitted successfully back to Earth, of which 6 were considered good enough for publication, they proved to be a revelation. Those 6 images covered 70% of the far side and opened a whole new perspective on the lunar surface. It was almost immediately evident that the dark patches that make the face of the man in the moon on the near side are almost completely absent on the far side. These dark patches are basaltic plains called mare, created by volcanic activity on the moon billions of years ago. Instead, the far side was littered with craters, even more so than the near side, and some of those craters were the size of small countries. The Soviets started naming many of the features they were seeing for the first time, an act which caused some controversy in what was known as the height of the Cold War era. We already had an inkling of one of those vast new craters, which is actually one of the very few mare on the far side. The subtlest hint of Mare Orientale, one of the largest impact craters known, seen on the limb of the moon, had been known of since its discovery by Julius Franz in 1906 and can be seen during good librations when that portion of the moon swings around towards us. The view from Luna 3 showed how vast an impact crater Orientale was, resembling a bullseye. It was almost 560 miles, 900 kilometers, across, pretty much the length of the United Kingdom give or take, and was caused by an asteroid impact, thought to be around 40 miles, 64 kilometers, wide just under 4 billion years ago. The resulting giant crater, termed an impact basin, was subsequently filled with volcanic lava. In 1965, another Soviet mission, Zond 3, flew by the moon with a far better camera than Luna 3 possessed and with the ability to conduct more detailed science observations, including spectroscopy. Zond 3 produced 23 very detailed photographs of the lunar far side, which enabled one of the first detailed maps of the entire lunar surface to be constructed. In the meantime, NASA was progressing its Apollo program at a phenomenal rate. Following the declaration by President Kennedy that the U.S. would place a man on the moon and return him safely to the Earth by the end of the 1960s, by December 1968 NASA was ready to send 3 people, Frank Borman, Jim Lovell, and Bill Anders, all the way around the moon and back for the Apollo 8 mission. They became the first humans in history not only to escape from low Earth orbit but also to see the elusive far side. This is how Lovell famously described the lunar surface. The moon is essentially gray, no color, looks like plaster of Paris or sort of a grayish beach sand. We can see quite a bit of detail. There's not as much contrast between that and the surrounding craters. The craters are all rounded off. There's quite a few of them, some of them are newer. Many of them look like, especially the round ones, look like hit by meteorites or projectiles of some sort. When the Apollo 8 spacecraft flew around the far side of the moon, the signal to Earth was cut off for around 10 minutes. This loss of signal was a daunting time for the flight crew and mission control. Apollo 8 was alone and truly cut off from Earth, venturing where no human had ever gone before. As the astronauts came back around from the far side, a collective sigh of relief was breathed by many of the flight team at Mission Control in Houston. Charlie Duke describes what it was like to be flying over the far side of the moon. The computer told us that we were out of contact with the Earth and that we had loss of signal, he says. Then, all of a sudden, there was sunrise. It was the most dramatic sunrise I've ever seen. In Earth orbit, you see the sun's glow on the horizon or the planet's atmosphere, and it gets brighter and brighter. The moon is different, though. There's instant sunlight with long shadows on the lunar surface. The far side of the moon was very rough back there. I would not have wanted to land in the backside of the moon. After the success of Apollo 8, Apollo 9 went back to vital low Earth orbital testing of the lunar module, so the next astronauts to visit the far side were Gene Cernan, John Young, and Tom Stafford on board Apollo 10 in May 1969, just 2 months before the historic landing of Apollo 11. However, while flying over the far side of the moon, the trio of astronauts encountered something strange, which in the last few years NASA has been forced to re-explain thanks to conspiracy theory documentaries airing on U.S. television. The facts had been well known since the 1970s. These strange events on Apollo 10 were manifest in the form of some very odd sounds. The radio systems on board the Apollo spacecraft were crude by modern standards, though state-of-the-art at the time. The command and lunar modules were relatively noisy environments according to most of the astronauts, with bumps and bangs combined with the whirring of fans and engine noise. What the Apollo 10 crew heard through the radio systems baffled them. They described it as being almost like that made by an electronic instrument called a theremin, often used in creepy science fiction B-movies of the 1950s and 60s, as well as on the Beach Boys song, Good Vibrations. Research has since proven that the sound was nothing more than an interference effect from those 1960s radio communications systems on board. With the onset of the moon landings, 2 astronauts would travel to the surface while a third remained on board the command module to orbit the moon alone, though all of them got chance to orbit the moon and see the far side before landing. The solo orbital journeys of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Warden's, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, who were the unsung heroes of the Apollo missions, are some of the bravest feats ever achieved by astronauts. They would spend days making quite detailed lunar observations from orbit, mapping features nobody had ever seen before. Al Warden's is often quoted as saying that his time alone was some of the best he had during the Apollo 15 mission. It was nice to be rid of those guys, as you can imagine. Being stuck in something the size of a family car for over a week, it got pretty crowded up there. Once Dave and Jim left, I felt like I had some real space to start to do my important work of mapping the lunar surface. But the far side, the views at certain times, when the sun and the Earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. A question often asked of the Apollo astronauts and flight teams is, why were all the missions just to the near side? We wanted to be in contact with the Earth, so we weren't able to land on the far side of the moon, says Charlie Duke. Should something have gone wrong while the astronauts were on the surface, they would not have been able to communicate directly with Earth. This would not be such a problem today, as satellites could be put into lunar orbit to relay communications. The far side is of growing interest to scientists, and potentially future planned human missions. Indeed, the possibilities for the far side of the moon are vast. For many decades, the astronomical and scientific community has wanted to put radio telescopes and optical telescopes on the far side. Observatories on the far side would be shielded from not only man-made radio interference from Earth, but also the glare of daylight on our planet. The telescopes could be built inside craters to avoid solar radiation, and would provide us with an unprecedentedly clear insight deep into the far reaches of the universe. we also have little true understanding of the processes that make the far side so vastly different in appearance to the near side. Why it is so scarred with impact craters and so lacking in volcanic mare is even more puzzling when you consider that when the moon formed, it was much closer to Earth, and may not have necessarily been tidally locked at that time, meaning there would have been nothing special about the hemisphere we dub the far side. Today, NASA's Lunar Reconnaissance Orbiter has mapped the near side and far side of the moon in exquisite detail. And China just launched the robotic Chang'e 4 mission, which will make the first ever landing on the lunar far side in early January. When humans do eventually return to the moon, the far side must be a goal for a landing. Understanding it will give us more insight into not only the moon's past, but also perhaps the moon's relationship with Earth, our own past. The first ever surface mission to the far side of the moon is underway. China's robotic Chang'e 4 spacecraft streaked away from Earth today, December 7th, launching atop a Long March 3B rocket from the Xichang Satellite Launch Center at about 1:23 p.m. Eastern Standard Time, 18:23 GMT, 2:23 a.m. on December 8 local China time. If all goes according to plan, Chang'e 4 will make history's first landing on the lunar far side sometime in early January. The mission, which consists of a stationary lander and a rover, will perform a variety of science work and plant a flag for humanity in a region that remains largely unexplored to date. The moon is tidally locked to Earth, meaning the natural satellite takes about the same amount of time to spin once on its axis as it does to orbit our planet. So, here on Earth, we always see the same face of our cosmic neighbor. That would be the near side. The far side remains forever out of view, and that explains why this obscured surface has yet to welcome a robotic visitor. Communicating with a far-side lander or rover is difficult, because the entirety of the moon's solid, rocky body would block direct signals traveling to and fro. To solve this problem, China launched a satellite called Queqiao this past May. Queqiao has set up shop at the Earth-Moon Lagrange Point 2, a gravitationally stable spot beyond the moon from which the satellite will be able to relay communications between Mission Control and Chang'e 4. The spacecraft's signals will likely be coming from the floor of Von Karman crater, a 115-mile-wide, 186 kilometers, hole in the ground that's the mission's expected landing site. Von Karman is part of the South Pole Aitken Basin, one of the biggest impact features in the solar system. It spans a whopping 1,600 miles, 2,500 kilometers, from rim to rim. Chang'e 4 features a total of 8 scientific instruments. The landers are called the Landing Camera, LCAM, the Terrain Camera, TCAM, the Low Frequency Spectrometer, LFS, and the Lunar Lander Neutrons and Dosimetry, LND, which was provided by Germany. The rover sports the Panoramic Camera, PCAM, the Lunar Penetrating Radar, LPR, the Visible and Near-Infrared Imaging Spectrometer, VNIS, and the Advanced Small Analyzer for Neutrals, ASIN, a contribution from Sweden. This gear will allow Chang'e 4 to characterize its surroundings in great detail. For example, the LFS will return data about surface composition, while the LPR will tease out the layered structure of the moon's subsurface. Such information could help scientists better understand why the lunar far side is so different from the near side. For example, huge, dark basaltic plains called Maria cover much of the near side but almost none of the far side. By the way, don't call the far side the dark side, it receives just as much sunlight as the near side. Chang'e 4 will also conduct some radio astronomy work, taking advantage of the peace and quiet on the far side, which is shielded from the radio chatter coming from Earth. Queqiao is collecting astronomy data as well, using an onboard instrument called the Netherlands-China Low Frequency Explorer. The spacecraft carries a biological experiment as well, a small tin containing fruit fly eggs and seeds of cotton, potato, and Arabidopsis plants. Researchers will keep tabs on how these organisms live and develop on the lunar surface. Chang'e 4 marks the latest step in China's ambitious, long-term moon exploration strategy. The nation launched the Chang'e 1 and Chang'e 2 spacecraft to lunar orbit in 2007 and 2010, respectively. In December 2013, Chang'e 3 put a lander and a rover named Yutu down on the moon's near side. Chang'e 4 was originally developed as a backup to Chang'e 3 but was repurposed after the latter's success. And in October 2014, China launched Chang'e 5T1, which sent a test capsule on an 8-day trip around the moon that ended in a parachute-aided touchdown here on Earth. All of this is leading up to the Chang'e 5 sample return mission, which could launch toward the near side as early as next year. The nation's line of robotic lunar missions is named after Chang'e, a moon goddess in Chinese mythology. And then there's the crude side of things. Chinese officials have said they want to land people on the lunar surface, though the timeline for this goal is unclear. The moon is not China's human spaceflight focus in the near term. The country is working to get a crewed space station up and running in Earth orbit by the early 2020s.